Hello my dear student, we have discussed the reactions of amine in the class. One of the reaction, that is Hofmann rearrangement reaction. The rearrangement which converts an amide to an amine with one carbon atom laced by the action of alkaline hypohalite or bromine in alkali is known as Hofmann rearrangement reaction. Once again, the rearrangement which converts an amide to an amine with one carbon atom less by the action of alkaline hypohalite or bromine in the presence of alkali is known as Hofmann rearrangement reaction. You can see here amide which do not have substitution on the nitrogen. In the amide, there is no substitution on nitrogen atom. Display molecular rearrangement to primary amine. In this rearrangement, the carbonyl carbon means this C double bond O. In this rearrangement, the carbonyl carbon atom of the amide is lost, means this carbonyl carbon is removed and the R group of amide gets attached to the nitrogen of the amide. Here C double bond O will be removed and R is directly attached with NH. The reaction is as follows. Amide in the presence of bromine water in alkali with water molecule, it converts in amine, means amide converts into primary amine. This rearrangement reaction is known as Hofmann rearrangement reaction. Mechanism involves 3 steps. Step 1, first is bromination of nitrogen. Second step is extraction of H plus ion by hydroxyl and rearrangement of anion. And third step is hydrolysis. We will see one by one. First step, bromination of amide. Amide molecule when react with bromine water, it converts into N-bromamide. Means one atom of bromine will attach with this amide group. Means it converted into N-bromamide. Next step is when N-bromamide will react with hydroxyl ion, it will form unstable bromamide ion, anion. Means here one lone pair of electron. In case of unstable ion, there is a 2 lone pair of electron, means it is unstable. It is very unstable. When this unstable ion wants to stabilize, so this bromamide anion will convert into acyl nitrine with loss of bromine atom. This acyl nitrine converts, that is actual rearrangement process will be done. So this acyl nitrine is converted into isocyanate. The C double bond O rearranged and this isocyanate ion will be formed. And last step is hydrolysis. This isocyanate will react with water molecule. With the loss of carbonate ion, it will produce primary amide. So the first step is amide is directly convert into the primary amide. Now we will see the stereochemistry of this Hofmann reaction. Interesting stereochemical observation is that if the migrating group R is chiral, you know that what is chiral. So the migrating group R is chiral, its configuration is retained in the product amine. It means the same configuration is having in the amine, produced amine. Thus this rearrangement is intramolecular. The rearrangement is intramolecular. We will see the evidences of this rearrangement is intramolecular. So this rearrangement is intramolecular and the migrating group does not become free but remains attached with the substrate in same way, example by breach transition state. We will see in the next evidences that the rearrangement is intramolecular has been supported by the following evidences. First, when Hofmann rearrangement is carried out with the mixture of meta-deuteriobenzamide and benzamide. Only meta-deuteroaniline and aniline are formed. This shows that the rearrangement is intramolecular. If it is intermolecular, then the cross products such as aniline and meta-deuteroaniline are formed. You can see here meta-deutero and benzamide. When Hofmann reaction will proceed with intramolecular, the product will form, that is meta-deuteroaniline and aniline. Means this C double bond CONH2, that is amide group, it converted into amine group. D remains as such, and this amide group it will convert into NH2 group. But if intermolecular process done, so the cross product will be formed. But in the case of this reaction, it will not produce aniline and meta-deuteroaniline, but only form meta-deuteroaniline and aniline. So it proved that this Hofmann rearrangement reaction is only and only intramolecular. Next, when optically active alpha phenyl propionamide undergoes Hofmann reaction, then alpha phenyl ethylamine having the same configuration is formed. We have discussed earlier that same configuration will remain in the product. So alpha phenyl propionamide, that in case of alpha phenyl propionamide, the C double bond O group will be removed and alpha phenyl ethylamine will be produced. In this case, all the substituents remain as such, only C double bond O will be removed in the presence of bromine water in the alkali. Next is rate of Hofmann reaction. In the Hofmann rearrangement, N-bromamide rearranged to isocyanate is one step with the loss of bromide ion. We have discussed earlier, this step is slow. But when the migrating group is aryl, means this migrating group is aryl, then the rate of Hofmann reaction gets increased. Why? Because the presence of electron releasing substituents. You can see here this G is electron releasing substituents in the aromatic ring, mean it withdraws electron. For example, in the case of substituted benzamide, here it is substituted benzamide with aryl group, so the rate of reaction will be increased comparison to alkyl. You can see here the reactivity order is OCH3 is higher rate, then CH3, then H, then chlorine, then only NO2. Various applications of this reaction. The first application is synthesis of primary aliphatic and aromatic amine. Second, preparation of aldehyde, and the preparation of anthranilic acids from the phthalimide. In the exam, conversions can be asked, that anthranilic acid from phthalimide. It is important. We will see one by one. First, synthesis of primary aliphatic amine and aromatic amine. The Hofmann reaction is useful for the conversion of carboxylic acids and their derivatives into primary amine having one carbon atom less than the starting material. Here we will see reaction of benzoic acid, conversion of benzoic acid into bromoaniline. Here benzoic acid, one molecule of benzoic acid will react with bromine water and in the presence of FeBr3, it will convert into para-bromobenzoic acid. That means the bromination of benzoic acid. When this acid will converts into amide in the presence of SOCl2 and NH3. So COOH converts into amide group, that is CONH2. Here the Hofmann reaction will be occurred. Then so CONH2 will converts into primary amine. So ultimately benzoic acid, it directly converts into para-bromoaniline with various steps. Sometime in exam they can ask conversion of benzoic acid from parabromoaniline. So this three steps you have to write. One thing that here carbon atom the derivatives into primary amine having one carbon atom less means here one carbon atom, but the product contain one less carbon atom means here 1 2 3 4 5 6 and 7 carbon atom, here only 1 2 3 4 5 and 6, so one carbon atom less. These are the various preparations of methylamine, aniline, benzylamine, etc. One interesting reaction is urea hydrazine from urea. So NH2CO, that is amide and amine. Amide urea NH2CO NH2 will converts into hydrazine. Only C double bond O group will be removed. Next, preparation of beta amino pyridine. It is prepared from the nicotinamide because it cannot be produced in good yield via nitration of pyridine. When we have done nitration of pyridine, it is very difficult. So we will prepare with nicotinamide. When nicotinamide will react with bromine water in the presence of alkali, it converts into this beta amino pyridine. But yield is only 60 to 70%. You can see this only C double bond O group will be removed. Third is preparation of amino acid. Various you will learn various amino acid in the next semester in biochemistry, but here beta alanine is one of the amino acid of 20. There are 20 different amino acids. One of them, that is beta alanine, is prepared by treating succinimide with bromine and caustic potash. Reaction takes place through the haloamide of succinic acid. It is succinic acid. Succinic acid converts into this intermediate in the presence of alkali. When this intermediate react with bromine water in the presence of potassium hydroxide, it converts into beta alanine. You can see here the C double bond O group will be removed. Okay. Next, the synthesis of anthranilic acid. Anthranilic acid is basic starting material for preparation of ortho-disubstituted benzene derivatives. This is phthalic anhydride. Phthalic anhydride, first of all, phthalic anhydride converts into thalidomide. This O will replaced with NH. This thalidomide will react, means chlorination of thalidomide, it converted into this intermediate, and this intermediate undergoes Hofmann rearrangement reaction. It converts into anthranylic acid. So this CONH2 group, it's converted into only NH2. So this C double bond O group will be removed and anthranylic acid will be formed. Sometime in exam they can they ask conversion of phthalic anhydride into anthranylic acid. So this three-step reaction, you have to write this three-step reactions. And last, that is preparation of aldehyde. Hofmann reaction is used to convert alpha beta unsaturated acid. You know that what is saturated acid and what is unsaturated acid. So the alpha hydroxy acid amide into aldehyde. You can see this is unsaturated acid. What is saturated acid? if only single bond in the structure, that is saturated acid. But here this is double bond, so it is unsaturated acid. When unsaturated acid will react with chlorine in the presence of sodium hydroxide, it converts into this intermediate, and in the presence of acid it converts into aldehyde. So this unsaturated acid converts into aldehyde. So these are the reactions and stereochemistry of Hofmann rearrangement reaction. Thank you.